Newton's rings is a phenomenon in optics that occurs when a planoconvex lens is placed in contact with a flat glass plate. It results in the formation of concentric circular fringes of equal thickness, known as Newton's rings. This phenomenon is caused by the interference of light waves reflected from the upper and lower surfaces of the air film trapped between the lens and the glass plate. Experiment to observe Newton's rings. The experiment to observe Newton's rings typically involves the following steps. A planoconvex lens is placed on a glass plate, ensuring that the convex side of the lens is in contact with the plate. The glass plate is usually placed on a well-illuminated optical bench or a light source. As a result of the air film formed between the lens and the glass plate, a series of concentric bright and dark circular fringes are observed. These fringes, called Newton's rings, appear due to the interference of light waves reflected from the top and bottom surfaces of the air film. The observed Newton's rings can be viewed through a microscope or by using a magnifying glass. The diameter of the rings is measured using a calibrated eyepiece or a measuring scale. The diameter of the rings is found to increase as we move away from the point of contact between the lens and the glass plate. The diameter of the rings is then used to determine the radius of curvature of the lens or the flatness of the glass plate. The interference pattern of the Newton's rings can be analyzed to study the characteristics of light waves, such as wavelength, refractive index, and the thickness of the air film. The experiment provides a practical demonstration of interference phenomena and allows for the measurement of the radius of curvature of lenses or the flatness of glass plates. It is commonly conducted in engineering physics or optics laboratories to understand the principles of interference and its applications in optical devices. Thanks for watching.